Hello, and welcome to a journey through the cosmos. Tonight we're going to drift together through the vast expanse of space, exploring its wonders, its mysteries, and its quiet beauty. Get comfortable. Let your body sink into wherever you're resting. Take a slow, deep breath in and let it out gently. There's nowhere you need to be, nothing you need to do. Just listen and let yourself float. We'll travel together through 100 fascinating facts about our universe, woven into a story that will carry you softly towards sleep. If your mind wanders, that's perfectly fine. If you drift off before we finish, that's exactly what should happen. So close your eyes if you haven't already, and let's begin our journey into the infinite night sky. The journey begins. Imagine yourself standing in a quiet field at twilight, watching as the first stars begin to appear. The nearest of those stars you see twinkling above you is called Proxima Centauri, and it lives about 4.2 light years away from Earth. That means the light you're seeing right now began its journey over 4 years ago, traveling at 670 million miles per hour just to reach your eyes in this moment. But let's stay closer to home for now, because our own star, our sun, is extraordinary enough on its own. Deep in the sun's core, the temperature reaches 27 million degrees Fahrenheit. It's so incredibly hot that hydrogen atoms fuse together to create helium, releasing the energy that warms your face on a summer afternoon. This process has been happening for about 4.6 billion years, and it will continue for roughly another 5 billion years before our sun transforms into something different entirely. The light that leaves the sun's core doesn't immediately reach us though. That's one of space's most beautiful secrets. Even though light travels so incredibly fast, it can take up to 100,000 years for a photon to journey from the center of the sun to its surface, bouncing and scattering through the dense plasma. But once it finally breaks free into space, it takes just 8 minutes and 20 seconds to reach Earth. So the sunshine touching your closed eyelids right now began the last part of its journey just 8 minutes ago. Our planet Earth, spinning quietly through space, is traveling around the sun at about 67,000 miles per hour. Yet you don't feel that motion at all as you lie here, peaceful and still. We're all cosmic travelers, moving through the universe at incredible speeds while we sleep, while we dream, while we simply exist. The moon, Earth's faithful companion, is slowly drifting away from us at a rate of about 1.5 inches per year. Millions of years ago, the moon was much closer, and it appeared much larger in the sky. The days were shorter then too, because the moon's gravitational pull has been gradually slowing Earth's rotation. 400 million years ago, the day on Earth lasted only about 22 hours. Time itself flows differently on a cosmic scale. Our moon isn't unique in the solar system though. Jupiter, that massive gas giant with its swirling storms, has at least 95 known moons orbiting around it. Some are tiny, barely more than captured asteroids, but others are worlds unto themselves. One of Jupiter's moons, called Ganymede, is actually larger than the planet Mercury. It's the biggest moon in our entire solar system, with its own magnetic field and possibly an ocean of liquid water buried deep beneath its icy crust. Speaking of oceans hidden beneath ice, another of Jupiter's moons, Europa, is one of the most intriguing places in our solar system. Beneath its frozen surface lies an ocean that may contain twice as much water as all of Earth's oceans combined. That dark, cold ocean, warmed by gravitational forces that flex and squeeze Europa's interior, might just harbor life. Somewhere in that alien sea, in the complete darkness beneath miles of ice, something might be living right now. And if we travel outward from Jupiter, past Saturn with its magnificent rings, past distant Uranus and Neptune, we eventually reach the edge of our solar system, a place called the heliopause, about 11 billion miles from the Sun. Only 2 human-made objects have ever crossed that boundary into interstellar space: Voyager 1 in 2012 and Voyager 2 in 2018. These spacecraft, launched in 1977, are still functioning, still sending back whispers of data from the space between stars. Messages that take over 22 hours to reach us, even traveling at the speed of light. Let that thought settle over you like a warm blanket. Humanity has touched the space between stars. We've sent pieces of ourselves out into the cosmos, and they're still out there, traveling onward into the eternal night, carrying golden records with sounds and images of Earth, love letters to the universe. Rest now and breathe as we continue our journey through the cosmos together. As you float here in this peaceful darkness, let's turn our attention to the vastness that surrounds everything we know. The Milky Way galaxy, our cosmic home, contains somewhere between 100 and 400 billion stars, each one a sun, perhaps with its own family of planets, worlds we'll never visit, skies we'll never see. And yet, they're all connected to us, all part of the same slowly spinning spiral of light and dust. Our galaxy is so immense that if you could somehow travel at the speed of light, it would take you 100,000 years to cross from one edge to the other. And yet, despite containing hundreds of billions of stars, the Milky Way is mostly empty space. If you could stand on one of those distant stars and look around, the nearest neighboring star might be trillions of miles away, an ocean of darkness between islands of light. At the very center of our galaxy, hidden behind vast clouds of dust and gas, lies something remarkable and terrifying. A supermassive black hole called Sagittarius A star. It weighs about 4 million times more than our Sun, and its gravity is so powerful that not even light can escape once it crosses the point of no return. This cosmic giant sits quietly at the heart of everything we see in our night sky, an ancient anchor around which our entire galaxy slowly wheels. But the Milky Way isn't alone in the universe. Our nearest galactic neighbor is called Andromeda, and it's actually moving toward us at about 250,000 miles per hour. Don't worry though, this is a very slow collision. Andromeda and the Milky Way won't begin to merge for another 4 billion years. When they do meet, it will be a cosmic dance lasting hundreds of millions of years as the two galaxies pass through each other, their stars never colliding, but their shapes transforming into something entirely new. Beyond Andromeda, beyond the dozens of smaller galaxies in our local group, the universe extends into distances that become almost meaningless. There are an estimated 2 trillion galaxies in the observable universe, 2 trillion islands of stars, each containing billions or hundreds of billions of suns. The numbers become so large, they lose their meaning. And perhaps that's all right. Perhaps the best we can do is simply wonder at it all. The observable universe itself stretches about 93 billion light years in diameter. This is larger than you might expect, considering the universe is only 13.8 billion years old. The universe has been expanding since the Big Bang, and not only expanding, but accelerating, pushed apart by something we call dark energy, a mysterious force that makes up about 68% of everything that exists. We can't see it, we can't touch it, we only know it's there because of what it does. In fact, all the normal matter we're familiar with, planets, stars, you, me, everything we can see and touch, makes up less than 5% of the universe. About 27% is something called dark matter, which we also can't see directly. We know it exists because of how it affects the movement of galaxies and the bending of light around massive objects. The universe, it turns out, is mostly made of things we don't understand yet, and there's something beautiful about that mystery. Speaking of light bending, one of space's most elegant phenomena is called gravitational lensing. When light from a distant galaxy passes by a massive object like another galaxy or a black hole, the gravity actually bends the path of the light, like looking through a cosmic magnifying glass. Sometimes this creates multiple images of the same distant object, or stretches it into rings and arcs across the sky. Einstein predicted this would happen, and he was right. Space itself can curve and bend. Time bends too. The faster you move through space, the slower you move through time, relative to someone standing still. An astronaut aboard the International Space Station, orbiting Earth at 17,500 miles per hour, ages just slightly slower than people on the ground. The difference is tiny, After 6 months in space, they've aged about 0.005 seconds less than they would have on Earth. But it's real. Time is not the constant we imagine it to be. Let yourself drift deeper now, like floating in the warm darkness between stars, feeling the weight of your body melting away, breathing slowly, peacefully. Let's travel back in time now to the very beginning. 13.8 billion years ago, everything that exists, all of space, all of matter, all of energy, was compressed into a point smaller than an atom. And then, in an instant that we call the Big Bang, the universe began to expand. Not an explosion into empty space, but space itself expanding, carrying everything with it. In the first second after the Big Bang, the universe was unimaginably hot, 10 billion degrees. It was so dense and so energetic that matter as we know it couldn't even exist yet. Just a soup of particles and energy, expanding and cooling. But the universe learns quickly. Within 3 minutes, it had cooled enough for the first atomic nuclei to form. The seeds of hydrogen and helium, the simplest elements, the building blocks of stars. For the next 380,000 years, the universe remained opaque, filled with a fog of particles that scattered light in every direction. But then, as it continued to cool, something magical happened. The fog cleared. Electrons joined with nuclei to form the first complete atoms. And for the first time, light could travel freely through space. This ancient light, stretched and cooled by billions of years of expansion, still surrounds us today. We call it the cosmic microwave background radiation, the afterglow of creation itself, with a temperature now of just 2.7 degrees above absolute zero. The first stars didn't ignite until about 100 million years after the Big Bang. These ancient suns were massive, perhaps 100 times larger than our sun, and they burned bright and fast, living only a few million years before exploding as supernovas. But their deaths were not endings. In the hearts of these dying stars, crushed by unimaginable pressures and temperatures, the first heavy elements were forged. Carbon, oxygen, iron, gold, all the elements heavier than hydrogen and helium were created inside stars and scattered across space when those stars died. This means that the calcium in your bones, the iron in your blood, the carbon that forms the structure of every cell in your body, all of it was created billions of years ago inside a star that lived and died before our sun was even born. You are, quite literally, made of stardust. We all are. Every living thing on Earth, every mountain, every ocean, all of it built from the ashes of ancient stars. Our sun and solar system formed about 4.6 billion years ago from a cloud of gas and dust, the remnants of previous generations of stars. As gravity pulled this cloud together, it began to spin, forming a disk. At the center, pressures and temperatures grew until nuclear fusion ignited and our sun was born. In the disk around it, dust particles began to stick together, forming larger and larger clumps, pebbles, then boulders, then asteroids, and finally, planets. The Earth itself formed through countless collisions, billions of rocky bodies smashing together over millions of years, their combined gravity pulling them into a sphere. The heat from all these impacts, combined with the decay of radioactive elements, melted the early Earth into an ocean of magma. Slowly, over millions of years, the surface cooled and solidified. But the interior remains hot even today. The outer core of our planet is still liquid iron, spinning and generating the magnetic field that protects us from harmful solar radiation. About 4.5 billion years ago, when Earth was still very young, something catastrophic happened. A Mars-sized planet called Theia collided with Earth in a glancing blow. The impact vaporized both Theia and a large portion of Earth's crust, sending debris spraying into orbit. This debris gradually came together under its own gravity, forming our moon. So the moon is not just Earth's companion. It's actually a piece of Earth itself, born from a cosmic collision in the violent early days of our solar system. The moon's presence has been essential for life on Earth. Its gravitational pull stabilizes Earth's axial tilt, preventing wild climate swings that would make complex life difficult. It creates our tides, mixing nutrients in the oceans. Some scientists believe that life might have first emerged in tidal pools, where the regular rhythm of the moon's pull concentrated organic molecules and provided energy for chemical reactions. The moon above you now, quiet and peaceful, may have been midwife to all life on our planet. Rest here in this knowledge that you are connected to everything, born from stars, living on a planet shaped by cosmic forces, part of an unbroken chain reaching back to the beginning of time itself. Let your breathing deepen, slow and steady, as we drift forward through time to the universe as it exists today, full of wonders both beautiful and strange. Out beyond Neptune, in the frozen reaches of our solar system, there exists a region called the Kuiper Belt. This is a vast disk of icy bodies, leftover debris from the formation of the planets, stretching from about 30 to 50 astronomical units from the Sun. Pluto lives here, along with countless other dwarf planets and comets. It's a twilight realm where the Sun appears as just a bright star, and temperatures hover near absolute zero. One of the most fascinating objects in the Kuiper Belt is called Haumea, a dwarf planet that spins so incredibly fast, completing one rotation every 4 hours, that it's been stretched into an elongated shape, like a cosmic football tumbling through the darkness. Even farther out, beginning about 2,000 astronomical units from the Sun, lies the Oort cloud. This is a vast spherical shell of icy objects surrounding our entire solar system, extending perhaps halfway to the nearest star. We've never actually observed the Oort cloud directly. It's too far away, too dark. But we know it must be there because of the long period comets that occasionally fall inward toward the Sun, taking thousands or even millions of years to complete a single orbit. These ancient travelers, disturbed from their distant home by the gentle gravitational nudges of passing stars, bring us messages from the edge of the Sun's influence. Comets themselves are beautiful time capsules. When they approach the Sun, the ice on their surface begins to vaporize, creating those magnificent tails that stretch for millions of miles. But those tails don't trail behind the comet like you might expect. Solar wind, the stream of charged particles constantly flowing outward from the Sun, pushes the comet's tail so that it always points away from the Sun, regardless of which direction the comet is traveling. A comet's tail can actually precede it as it moves away from the Sun after passing its closest approach. Back in the inner solar system, Venus holds secrets beneath its crushing atmosphere. The atmospheric pressure on Venus's surface is 92 times greater than Earth's, equivalent to being almost a kilometer beneath the ocean. The atmosphere is thick with carbon dioxide, creating a runaway greenhouse effect that makes Venus the hottest planet in our solar system, with surface temperatures reaching 870 degrees Fahrenheit, hot enough to melt lead. And yet, about 30 miles above that hellish surface, in Venus's upper atmosphere, temperatures and pressures are remarkably Earth-like. Some scientists have speculated that microbial life might exist there, floating in the clouds, sustained by chemical reactions we don't yet understand. Mars, our rusty red neighbor, tells a different story. It was once a world of water. Ancient river valleys carved into its surface show where water once flowed freely. Minerals detected by rovers indicate that Mars once had lakes, possibly even a vast ocean covering much of its northern hemisphere. But about 3.5 billion years ago, Mars lost most of its atmosphere, blown away by the solar wind after the planet's magnetic field collapsed. The water either escaped to space or froze beneath the surface. Today, Mars is cold and dry, but that water is still there, locked in polar ice caps and buried in the soil. Future human explorers will be able to extract it. Speaking of Mars, a Martian day, called a sol, is only about 40 minutes longer than an Earth day. This similarity is remarkably convenient for future colonization. But here's something wonderful. Because Mars is farther from the Sun, a Martian year is almost twice as long as an Earth year. 687 Earth days. The seasons on Mars last twice as long too, though they're much harsher than ours. In winter, It gets cold enough that carbon dioxide freezes out of the atmosphere and falls as dry ice snow on the polar caps. Saturn's rings, those magnificent bands of ice and rock, are surprisingly thin. Though they stretch over 175,000 miles from edge to edge, they're only about 30 feet thick in most places, thinner proportionally than a sheet of paper. The rings are made of countless particles, ranging in size from tiny grains to house-sized boulders, all orbiting Saturn in an intricate gravitational dance. Scientists believe the rings might be relatively young, perhaps only a few 100 million years old, possibly formed when a moon wandered too close to Saturn and was torn apart by tidal forces. Within Saturn's system of moons, Titan stands out as one of the most Earth-like worlds we've discovered. It's the only moon in our solar system with a substantial atmosphere, thicker than Earth's, actually. Titan has weather, with clouds and rain, though the rain is liquid methane and ethane, not water. It has rivers and lakes and seas on its surface, all filled with liquid hydrocarbons. Standing on Titan's surface would feel oddly familiar in some ways. A thick, hazy sky, familiar atmospheric pressure, but the temperature is negative 290 degrees Fahrenheit, and you'd be standing beside a lake of liquid natural gas. One of the strangest moons in our solar system is Enceladus, another of Saturn's family. This small, icy moon is only about as wide as Arizona, and yet it's geologically active. Massive geysers of water vapor and ice particles erupt from cracks near its south pole, shooting hundreds of miles into space. These plumes contain organic molecules and salts, evidence that beneath Enceladus's frozen crust lies a global ocean of liquid water. Like Europa, this makes Enceladus one of the most promising places to search for extraterrestrial life. Life that might exist right now in the warm darkness beneath the ice. Let these alien worlds drift through your thoughts like clouds, strange and beautiful, while you sink deeper into rest. Floating peacefully now, let's turn our gaze beyond our solar system to the countless worlds that orbit distant stars, places we're only just beginning to discover. The first planet orbiting a sun-like star beyond our solar system was discovered in 1995. It was called 51 Pegasi b, a giant world larger than Jupiter, orbiting so close to its star that its year lasted only 4 days. This discovery opened the floodgates. Since then, we've confirmed the existence of over 5,000 exoplanets, worlds beyond our solar system, and we've only just begun to search. Statistical analysis suggests that nearly every star in our galaxy has at least one planet. That means there could be hundreds of billions of planets in the Milky Way alone. Some of these distant worlds are utterly unlike anything in our solar system. There are planets made of diamond, compressed carbon so dense and crystallized by immense pressures that the entire world glitters. There are worlds where it rains glass sideways, driven by winds howling at 4,000 miles per hour. There are rogue planets wandering through interstellar space without any star to call home, ejected from their birth systems and doomed to drift alone through the cosmic darkness forever. One of the most intriguing types of exoplanets we've discovered are super-Earths. Rocky planets larger than Earth, but smaller than Neptune. Our solar system doesn't have any planets this size, but they appear to be incredibly common throughout the galaxy. Some orbit in their star's habitable zone, that precious range of distances where temperatures allow liquid water to exist on a planet's surface. A planet called Kepler 452b orbits a sun-like star about 1,400 light-years away, taking 385 days to complete 1 year. It's about 60% larger than Earth and receives just slightly more starlight than we do. We don't know if it has oceans, continents, or even life, but it could. Somewhere out there, under an alien sun, waves might be lapping on a shore we'll never see. The search for life beyond Earth is one of humanity's most profound questions. We know that life arose on Earth relatively quickly. Geological evidence suggests living organisms existed as early as 3.8 billion years ago, only about 700 million years after Earth's formation. If life can begin that rapidly when conditions are right, perhaps it's common throughout the universe. But we also know that complex, intelligent life might be extraordinarily rare. Earth has been inhabited for billions of years, but humans and our technology have only existed for an evolutionary eye blink. One way we search for intelligent life is by listening. The search for extraterrestrial intelligence, or SETI, uses radio telescopes to scan the sky for signals that might indicate technological civilizations. Radio waves travel at the speed of light and can cross vast interstellar distances with relatively little interference. If a civilization 100 light-years away started broadcasting radio signals today, we could detect them in the year 2125. And if we responded, they would receive our message in 2225. Conversations across interstellar space would take generations. The famous Arecibo message was broadcast toward a cluster of stars in 1974. It was a simple radio transmission containing basic information about humanity, Earth, and our DNA. That message has now traveled 50 light-years from Earth, crossing through empty space at the speed of light. It won't reach its intended destination, a globular cluster 25,000 light-years away, for another 25,000 years. The civilizations that might receive it haven't even evolved yet. Perhaps the most humbling fact about space is something called the Fermi paradox. If the universe is so vast, so old, and contains so many planets, where is everyone? If intelligent life is common, we should see evidence of it everywhere. Vast engineering projects, radio signals, spacecraft. The galaxy is 13 billion years old. If another civilization had arisen even 1 million years before us and developed interstellar travel, they would have had time to colonize the entire galaxy by now. So where are they? The silence is called the Great Silence, and it's one of the deepest mysteries we face. There are many possible explanations. Perhaps intelligent life is extraordinarily rare. Perhaps civilizations tend to destroy themselves shortly after developing advanced technology. Perhaps the distances are simply too vast and the speed of light too limiting for civilizations to ever meet. Or perhaps advanced civilizations are out there, but they're so different from us, so far beyond our understanding that we can't recognize their presence. We might be like ants trying to understand the internet. Some scientists think we might be living in a special time, the brief window when we're technologically advanced enough to ask these questions, but not yet advanced enough to answer them. In a few decades or centuries, we might detect biosignatures in the atmospheres of distant exoplanets, oxygen and methane in combinations that suggest living processes. We might find microbial life on Mars or Europa or Enceladus, proving that life arose independently elsewhere in our own solar system. Or we might detect that one unmistakable signal from the stars, a message that tells us we're not alone. Until then, we keep searching, keep wondering, keep looking up at the night sky with hope and curiosity, knowing that the answer, whatever it is, will change everything about how we understand our place in the cosmos. Breathe slowly. Let these thoughts drift away like stars disappearing into dawn. Sink deeper into peace. Drifting deeper now, let's explore the most extreme objects in the universe. Places where the laws of physics are pushed to their absolute limits. Neutron stars are among the strangest objects we've ever discovered. When a massive star exhausts its fuel and explodes as a supernova, sometimes its core survives, crushed by gravity into a sphere only about 12 miles across. But that tiny sphere contains more mass than our entire sun. A neutron star is so dense that a teaspoon of its material would weigh about 4 billion tons on Earth. The atoms have been crushed so completely that electrons and protons have merged into neutrons, packed together so tightly there's no empty space left between them. It's matter at the very edge of what's physically possible. Some neutron stars spin incredibly fast, rotating hundreds of times per second. These are called pulsars, and they emit beams of radiation from their magnetic poles, like cosmic lighthouses. As the neutron star spins, these beams sweep across space, and if Earth happens to lie in their path, we detect regular pulses of radio waves with extraordinary precision. The fastest known pulsar rotates 716 times per second. Imagine something with more mass than the Sun, spinning so fast that a point on its equator is moving at about 20% the speed of light. When two neutron stars spiral together and collide, they create a killer nova, an explosion that produces gravitational waves rippling through space-time itself. In 2017, scientists detected both gravitational waves and light from such a collision, located about 130 million light-years away. This single event produced more gold, platinum, and rare earth elements than could be created by millions of years of normal stellar processes. The gold in any jewelry you wear, the platinum in catalytic converters. It was all created in the violent collision of neutron stars billions of years ago. Black holes take extreme physics even further. When a truly massive star collapses, nothing can stop gravity's final pull. The core compresses beyond even neutron star density, crushing down to an infinitely small point called a singularity. Around this singularity, gravity becomes so powerful that it creates an event horizon, a boundary beyond which nothing, not even light itself, can escape. Anything that crosses the event horizon is lost to the universe forever, falling toward the singularity in a journey that, from the outside, seems to take infinite time. Near a black hole, time behaves in ways that defy our everyday experience. If you could somehow survive near a black hole's event horizon and watch the universe, you would see time in the outside cosmos accelerating. Stars would be born, live, and die in what seemed like moments. If you spent just a few hours near the event horizon of a massive black hole and then returned to Earth, thousands or even millions of years might have passed. Time dilation becomes extreme where gravity is strongest. The largest black holes we know of are truly incomprehensible in scale. The black hole at the center of the galaxy, Messier 87, which scientists managed to image in 2019, has a mass of about 6.5 billion suns. Its event horizon is larger than our entire solar system. If you could somehow stand at the edge of our solar system and look inward, and this black hole replaced our sun, the event horizon would stretch past Pluto's orbit. The accretion disk of superheated matter spiraling into this black hole is brighter than 1 trillion stars. Quasars are what we see when supermassive black holes actively feed on vast amounts of matter. As gas and dust spiral inward at nearly the speed of light, friction heats the material to millions of degrees, making it shine with incredible brilliance. The most luminous quasars can be 1,000 times brighter than an entire galaxy of hundreds of billions of stars. We observe the most distant quasars as they appeared over 13 billion years ago, less than 1 billion years after the Big Bang. This tells us that supermassive black holes formed remarkably quickly in the early universe, though we still don't fully understand how. Space itself can be strange and counterintuitive. Despite what our senses tell us, there is no up or down in space, no absolute reference frame. An astronaut in orbit doesn't feel the sensation of falling, even though they're in constant free fall toward Earth. They're falling at exactly the right speed and direction to keep missing Earth, creating what we experience as weightlessness. Gravity doesn't disappear in orbit. It's still almost as strong as on Earth's surface. What changes is that everything falls together. The vacuum of space isn't truly empty. Quantum mechanics tells us that even in the purest vacuum, particle-antiparticle pairs constantly pop into existence and annihilate each other in tiny fractions of a second. This quantum foam underlies all reality, even the space between your atoms right now. And in the vacuum of space near a black hole's event horizon, something remarkable can happen. If a particle-antiparticle pair appears right at the edge of the event horizon, one particle might fall in, while the other escapes. From the outside, it appears as if the black hole is emitting radiation. This Hawking radiation means that black holes aren't truly black. They slowly evaporate over unimaginable spans of time. Rest now in this strange universe where time bends and space curves, where the impossible becomes merely improbable, and let yourself drift into dreams, breathing gently, softly, Let's journey now through the human experience of space, our attempts to reach beyond our world and touch the cosmos with our own hands. The first human being to leave Earth's atmosphere was Yuri Gagarin, a Soviet cosmonaut who orbited our planet on April 12, 1961. His flight lasted just 108 minutes, less than 2 hours. But in that brief time, he saw what no human had ever seen before. He watched the Earth turning slowly beneath him, saw the thin blue line of our atmosphere against the blackness of space, and spoke words that still resonate. The Earth is blue. How wonderful. It is amazing. That single orbit changed humanity forever, proving that we could leave our cradle and survive in the hostile environment beyond. The Apollo missions that followed in the 1960s pushed human exploration even further. Between 1969 and 1972, 12 human beings walked on the surface of the moon. They left behind footprints that will remain undisturbed for millions of years, preserved in the lunar dust, because there's no wind or weather to erase them. They also left behind scientific instruments, flags, and small mementos, including a plaque that reads, "We came in peace for all mankind." The last person to walk on the moon was Eugene Cernan in December 1972. As of now, over 50 years have passed since humans last stood on another world. The International Space Station, humanity's current outpost in space, has been continuously inhabited since November 2nd, 2000. That means there hasn't been a single moment in over 2 decades when all humans were on Earth. Right now, as you rest here, there are people living and working about 250 miles above your head, orbiting Earth every 90 minutes. They experience 16 sunrises and sunsets every single day. They work, eat, sleep, and dream while traveling at 17,500 miles per hour, seeing views that most of humanity can only imagine. Living in space changes the human body in fascinating ways. Without gravity constantly pulling down on their spines, astronauts grow about 2 inches taller in space. Their hearts become slightly smaller because they don't have to work as hard to pump blood throughout the body. Bone density decreases without the constant stress of supporting body weight. Even their sense of taste changes. Many astronauts report that food tastes more bland in space, which is why they often request spicier meals. The human body is so perfectly adapted to Earth's gravity that removing that constant force reveals just how much we depend on it. One of the most challenging aspects of long-duration spaceflight is isolation. Astronauts on the ISS can at least look down and see Earth, see the blue marble that's their home, just a few hours away if needed. But future missions to Mars will be different. The journey to Mars takes about 7 months with current technology, and once you're there, you can't simply come home if something goes wrong. You have to wait until Earth and Mars are properly aligned again, which happens only once every 26 months. A round-trip mission to Mars would likely take at least 2 to 3 years, with astronauts spending many months on the Martian surface. looking up at a sky where Earth appears as just another star. The farthest distance any human has travelled from Earth was achieved during the Apollo 13 mission in 1970. When their spacecraft swung around the far side of the moon, the crew reached a distance of 248,655 miles from home. At that moment, they were farther from help, from safety, from any other human being than anyone has ever been. And they were facing a crisis. An oxygen tank had exploded, crippling their spacecraft. But through ingenuity, teamwork, and remarkable calm under pressure, they made it home safely. Their survival is a testament to human resilience and problem solving. Space travel has given us perspectives we couldn't have gained any other way. Astronauts often describe experiencing something called the overview effect, a cognitive shift that occurs when viewing Earth from space. Seeing our planet as a whole, a fragile blue sphere floating in the infinite darkness, the thin atmosphere like a soap bubble that contains all life we know. It changes something fundamental in how people see their place in the universe. The borders that divide nations become invisible. The conflicts that seem so important from the ground fade into insignificance against the backdrop of the cosmos. The Hubble Space Telescope, launched in 1990, has been humanity's window into the deep universe for over 3 decades. Orbiting above Earth's distorting atmosphere, it has captured images of galaxies billions of light years away, witnessed the birth and death of stars, and helped us measure the age and expansion rate of the universe itself. One of its most famous images is the Hubble Deep Field, created by pointing the telescope at a seemingly empty patch of sky, no bigger than a grain of sand held at arm's length. In that tiny section of darkness, Hubble revealed 3,000 galaxies, each containing billions of stars. This image showed us that wherever we look in the universe, we find countless galaxies stretching away into infinity. The James Webb Space Telescope, launched in 2021, has now taken Hubble's mission even further. With its massive mirror and infrared sensors, Webb can see the universe's first galaxies, formed just a few 100 million years after the Big Bang. It can peer through dust clouds to watch stars being born. It can analyze the atmospheres of distant exoplanets, searching for the chemical signatures that might indicate life. Each image it sends back reveals universes within universes, structures and beauties we never imagined existed. Let these achievements wash over you like gentle waves, humanity reaching upward, outward, driven by curiosity and wonder. While you rest here, safe and peaceful, breathing slowly, drifting, sinking deeper into rest. Let's explore the architecture of the cosmos, the grand structures that organize the universe on its largest scales. Galaxies don't scatter randomly through space. They gather together in clusters, and those clusters connect in vast filaments and sheets, creating a cosmic web that spans billions of light years. Our own Milky Way belongs to what we call the local group, a collection of about 80 galaxies spanning roughly 10 million light years across. But the local group is just a small suburb in a much larger structure. We're part of the Virgo supercluster, which contains at least 100 galaxy clusters and spans about 110 million light-years. But even that isn't the full picture. Recent observations have revealed that the Virgo supercluster is itself just one lobe of an even more immense structure called Laniakea, a supercluster of superclusters containing about 100,000 galaxies with a total mass of about 100 million billion suns. The name Laniakea comes from Hawaiian, meaning immeasurable heaven, and it's a fitting description for our cosmic neighborhood. All of these galaxies are slowly flowing through space, pulled by gravity toward a mysterious region called the Great Attractor. The Great Attractor is a gravitational anomaly located about 220 million light-years away in the direction of the constellations Triangulum Australe and Norma. Something there, possibly a massive concentration of galaxies hidden behind the dust and stars of our own Milky Way, is pulling our entire local group, along with hundreds of thousands of other galaxies, toward it at about 600 kilometers per second. We can't see it directly because it lies in what astronomers call the zone of avoidance, where the dense matter of our galaxy's disk blocks our view. But we can measure its gravitational influence on everything around it. Between these vast structures of galaxies lie enormous voids, regions of space containing very few galaxies at all. The Boötes void, discovered in 1981, is one of the largest known. It spans about 330 million light-years across, a bubble of near emptiness in the cosmic web. If the Milky Way were located in the center of the Boötes void, we wouldn't have known that other galaxies existed until the 1960s. The nearest galaxies would have been too distant and too faint for earlier telescopes to detect. Our night sky would have been much lonelier. The cosmic web itself formed from tiny variations in density in the very early universe. Where matter was slightly more concentrated, gravity pulled in more matter, creating the seeds of galaxy clusters. Where matter was slightly less dense, it got pulled away, creating the voids. Computer simulations of the universe's evolution, starting from just after the Big Bang and running forward billions of years, reproduce structures remarkably similar to what we actually observe. The patterns we see in galaxy distributions today were written into the fabric of space when the universe was just 380,000 years old. Light itself tells us stories about the universe's structure and history. When light travels through expanding space for billions of years, the expansion stretches the light waves, shifting them toward the red end of the spectrum. This redshift tells us how far away a galaxy is and how fast it's moving away from us. The most distant galaxies we've observed have redshifts so extreme that their ultraviolet light has been stretched all the way into the infrared. These galaxies are so far away that we see them as they appeared more than 13 billion years ago, when the universe was young and stars were just beginning to form. Some of the light reaching us has traveled for so long that the galaxies that emitted it no longer exist in the form we see them. We're looking at ghosts, images of galaxies as they were billions of years ago, light that has been traveling through space since before Earth even existed. Some of those galaxies have since collided with others or exhausted their gas and stopped forming stars.
or been torn apart by gravitational interactions. We're seeing their past, preserved in photons that have been journeying through space for eons. The universe itself has no center and no edge. When we say the universe is expanding, we don't mean it's expanding into something. There is no outside. Space itself is stretching, carrying galaxies away from each other like raisins in rising bread dough. Every point in the universe can consider itself the center, because from every perspective, distant galaxies are moving away in all directions. The Big Bang didn't happen at a particular location. It happened everywhere simultaneously, and we exist within the expanding aftermath of that initial moment. As the universe expands, it also thins out. Billions of years from now, the accelerating expansion driven by dark energy will carry distant galaxies beyond our cosmic horizon. Their light will be stretched so much that it becomes undetectable. Future astronomers, living trillions of years from now in a universe grown cold and sparse, will look up at a sky containing only their local cluster of galaxies. The cosmic microwave background will have faded to invisibility. They'll have no way to know that the universe was once different, no way to discover the Big Bang or the cosmic web. They'll live in a much lonelier cosmos, and they might never know that their universe was once filled with light. But that's unimaginably far in the future. For now, we live in a golden age, when the universe is mature enough to have formed complex structures and life, but young enough that we can still see its history written in the sky. We can look back toward the beginning and forward toward the far future. We are witnesses to the cosmos in its prime. Rest in that knowledge that you exist in this precious moment, when the universe can know itself through your eyes. Breathing slowly, peacefully, drifting through the infinite night. Breathing deeply, effortlessly. Let's turn our attention to the phenomena that fill the space between worlds, the cosmic weather and radiation that flows through the universe. The sun doesn't just give us light and heat. It constantly streams particles outward into space in what we call the solar wind. This wind is made of charged particles, mostly electrons and protons, flowing outward from the sun's corona at speeds between 250 and 500 miles per hour second. The solar wind carries with it the sun's magnetic field, creating a bubble around our entire solar system called the heliosphere. This bubble extends far beyond the planets, protecting us from some of the harsh radiation that pervades interstellar space. When the solar wind encounters Earth's magnetic field, beautiful things happen. The charged particles are funneled along our planet's magnetic field lines toward the poles, where they collide with atoms in the upper atmosphere. These collisions excite the atoms, causing them to emit light in shimmering curtains and waves. The aurora borealis in the north and aurora australis in the south. The colors depend on which atoms are struck. Oxygen produces green and red, while nitrogen creates blue and purple. Some auroras dance and flicker, responding in real time to changes in the solar wind, painting the polar skies with ethereal light. Sometimes the sun releases more than just steady wind. Solar flares and coronal mass ejections can blast billions of tons of plasma into space at millions of miles per hour. When these storms strike Earth, they can create auroras visible much farther from the poles than usual, sometimes as far south as the Caribbean or as far north as Australia. But they can also disrupt satellites, interfere with radio communications, and in extreme cases, damage power grids. The largest solar storm on record, the Carrington event of 1859, was so powerful that auroras were seen near the equator, and telegraph systems sparked and caught fire. If such a storm struck today, it could cause trillions of dollars in damage to our technology-dependent civilization. Other planets experience auroras too, but on scales that dwarf Earth's displays. Jupiter's auroras are larger than our entire planet, powered not just by the solar wind, but also by its moon Io, which spews out a ton of material every second from its volcanic eruptions. This material becomes ionized in Jupiter's powerful magnetic field, creating electrical currents millions of times stronger than anything on Earth. The energy released by Jupiter's auroras could power all of human civilization many times over. Between the planets, space is filled with cosmic rays, high-energy particles, mostly protons, traveling at nearly the speed of light. Some come from our sun, but the most energetic ones originate from supernovas, pulsars, and black holes scattered throughout the galaxy. These particles carry tremendous energy. The most powerful cosmic ray ever detected, nicknamed the Oh My God particle in 1991, had as much kinetic energy as a baseball thrown at 60 miles per hour, concentrated in a single subatomic particle. Where it came from and how it achieved such energy remains a mystery. Cosmic rays constantly bombard Earth, but our atmosphere and magnetic field protect us. When a high-energy cosmic ray strikes the upper atmosphere, it creates a cascade of secondary particles called an air shower. A single cosmic ray can produce billions of particles, spreading across several square miles. At any given moment, about one cosmic ray particle passes through your body every second. You've been gently irradiated by the universe your entire life, a connection to the violent events happening in distant galaxies. Interstellar space itself isn't truly empty. Between the stars lies the interstellar medium, wispy clouds of gas and dust so thin that it's still far better than any vacuum we can create on Earth. Yet this gossamer material, accumulated across light years, provides the raw material for new stars. In the denser regions of the interstellar medium, clouds of molecular hydrogen slowly collapse under their own gravity. The process takes millions of years, but eventually these clouds fragment and compress, heating up until nuclear fusion ignites and new stars are born. Some of the most beautiful objects in space are nebulae, clouds of gas and dust illuminated by nearby stars. The Orion Nebula, visible to the naked eye as a fuzzy star in Orion's sword, is a stellar nursery about 1,300 light-years away, where thousands of stars are currently forming. It spans about 24 light-years across, and within its glowing clouds, we can see protoplanetary disks, planets in the process of formation around young stars. We're witnessing the birth of solar systems that millions of years from now might harbor worlds with their own stories to tell. Other nebulae mark the end of stars' lives rather than their beginning. Planetary nebulae, despite their misleading name, are the outer layers of dying sun-like stars, expelled into space as the star exhausts its fuel. These expanding shells of glowing gas create some of the most intricate and beautiful structures in space. The Ring Nebula, the Helix Nebula, the Cat's Eye Nebula, each one unique, each one the final breath of a star that lived for billions of years. In about 5 billion years, our own sun will create such a nebula, its outer layers drifting away while its core collapses into a white dwarf, a fading ember that will cool slowly over trillions of years. Let these images fill your mind. Glowing nebulae and dancing auroras, particles streaming through space at the speed of light, the universe alive with motion and energy. While you rest here, still and peaceful, breathing gently, floating in the cosmic dance. Almost there now, breathing slowly, peacefully. Let's complete our journey through the cosmos by contemplating the deepest questions, the ultimate fate of everything, and our place in this vast tapestry. The universe is currently about 13.8 billion years old, but its story is far from over. For the next several trillion years, galaxies will continue forming stars from their remaining gas, though at an ever-decreasing rate. The universe is slowly running out of the raw materials needed to make new stars. In about 5 to 6 trillion years, the last normal star will be born. After that, only the longest-lived stars, tiny red dwarfs that burn their fuel so slowly they can shine for 10 trillion years or more, will remain to light the cosmos. Eventually, even those will fade. In about 100 trillion years, the last stars will exhaust their fuel and die, leaving behind white dwarfs, neutron stars, and black holes. The universe will enter what scientists call the degenerate era, a time when the only light comes from the occasional collision of brown dwarfs or the dim radiation from cooling stellar remnants. Galaxies will still exist as gravitational structures, but they'll be dark, invisible islands in an ever-expanding sea of space. As time stretches into the unimaginable future, 10 to the 40th years from now, even the black holes will begin to evaporate through Hawking radiation. The most massive black holes, the supermassive monsters at the centers of galaxies, will be the last objects of substantial mass in the universe. But they too will eventually decay, taking 10 to the 100th years to completely evaporate. When the last black hole finally radiates away its last particle, nothing will remain but a thin soup of photons and fundamental particles, spreading ever farther apart in the eternal expansion. This might sound melancholy, but there's something profound in it too. The universe is spending its energy and complexity to create moments like this one, to create stars and planets, life and consciousness, beauty and wonder. Every sunset, every thought, every feeling you've ever had represents the universe using its finite resources to experience itself. You are the cosmos becoming aware of its own existence, even if just for a brief flicker in cosmic time. The fact that we exist at all is extraordinary when you consider the odds. The fundamental constants of physics, the strength of gravity, the mass of electrons, the rate of universal expansion, all had to fall within incredibly narrow ranges for stars to form, for chemistry to work, for life to be possible. If any of these values were even slightly different, the universe would be a sterile void of formless particles, or nothing but black holes. Some scientists estimate the probability of a life-permitting universe at 1 in 10 to the power of 122. We live in a universe that seems fine-tuned for complexity and consciousness. This has led some to wonder if our universe is just one among many. The multiverse hypothesis suggests that perhaps countless universes exist, each with different physical laws and constants. In most of them, nothing interesting happens. No stars, no atoms, no observers. But in a tiny fraction, conditions are just right, and those are the only universes that can be observed by conscious beings like us. We exist in this universe not because it was designed for us, but because we could only exist in a universe like this. It's a selection effect written across cosmic scales. Space holds more mysteries still, more wonders to contemplate as you drift deeper into rest. The coldest place in the universe isn't in the depths of space, but actually here, on Earth. Scientists have created temperatures within a billionth of a degree above absolute zero in laboratories, colder than anywhere in the natural universe. Space itself hovers at about 2.7 degrees above absolute zero, warmed by the afterglow of the Big Bang. Mercury, the closest planet to the Sun, experiences the most extreme temperature variations in our solar system. Its sunlit side reaches 800 degrees Fahrenheit, hot enough to melt lead, while the night side plunges to minus 290 degrees Fahrenheit. This is because Mercury has almost no atmosphere to distribute heat, and it rotates so slowly that one day on Mercury lasts 176 Earth days. Venus rotates so slowly and in the opposite direction to most planets that on Venus, the Sun rises in the west and sets in the east. Even stranger, a day on Venus, one complete rotation, takes 243 Earth days, which is actually longer than Venus's year of 225 Earth days. This means that on Venus, a day is longer than a year. Saturn is the least dense planet in our solar system. Its density is so low, less than water, that if you could find an ocean large enough, Saturn would float. This is because Saturn is composed mostly of hydrogen and helium gas, with only a small rocky core deep within. The asteroid belt between Mars and Jupiter contains millions of rocky bodies. But despite what science fiction might suggest, the total mass of all asteroids combined is less than 4% of our Moon's mass. If you were traveling through the asteroid belt, you'd likely need a telescope to see the nearest asteroid. They're spread across such vast distances that empty space dominates. Neptune has winds that are the fastest in the solar system, reaching speeds of up to 1,200 miles per hour. That's faster than the speed of sound on Earth. These supersonic winds whip around the planet's equator, driven by internal heat and Neptune's rapid rotation. One of Jupiter's most famous features is the Great Red Spot, a storm larger than Earth that has been raging for at least 187 years, since we first observed it in 1831, though it may be much older. Though it has been slowly shrinking over the past century, Uranus is tilted on its side at an angle of 98 degrees, meaning it essentially rolls around the Sun like a ball. This extreme tilt means that Uranus's poles get 42 years of continuous sunlight, followed by 42 years of darkness. Scientists believe this unusual orientation resulted from a collision with an Earth-sized object billions of years ago. The largest volcano in our solar system is Olympus Mons on Mars, standing about 16 miles high, nearly 3 times the height of Mount Everest. Its base is the size of the entire state of Arizona. If you stood on the summit of Olympus Mons, you'd be above most of Mars's thin atmosphere, able to see the curve of the planet's horizon. Space smells strange, according to astronauts who have experienced it. When they return from spacewalks, they report that their spacesuits carry a distinctive odor, described as a mix of seared steak, hot metal, and welding fumes. This smell comes from dying stars, specifically from polycyclic aromatic hydrocarbons, complex carbon molecules created in the final moments of a star's life, and now floating through space, clinging to the exterior of spacecraft. But perhaps the most important fact about space is how it connects us to each other. Every human who has ever lived has looked up at the same stars, wondered at the same moon, been warmed by the same sun. The light from distant galaxies that reaches your eyes tonight has been traveling for billions of years. It existed before Earth formed, and it will continue its journey long after we're gone. You are connected through starlight to the deep past and the far future. The atoms in your body were forged in the cores of ancient stars, scattered into space by supernovas, gathered into clouds that formed our solar system, incorporated into Earth, and eventually assembled into the miracle of your living form. You are made of star stuff, as Carl Sagan famously said. And when you eventually return to the Earth, those atoms will persist, perhaps one day becoming part of another living being, or drifting back into space to be incorporated into future stars. In that sense, you are eternal, not as an individual, but as an essential part of the universe's ongoing transformation. We are the universe's way of knowing itself. Through our eyes, the cosmos beholds its own beauty. Through our minds, it contemplates its own existence. Through our hearts, it feels wonder at its own majesty. You are not separate from the universe. You are a part of it, as essential as any star or galaxy. Your consciousness is as much a fundamental feature of reality as gravity or light. And so, as you drift now into sleep, know that you carry the cosmos within you. The same forces that shape galaxies also shape your thoughts. The same laws that govern stars also govern your heartbeat. You are both infinitesimally small and infinitely precious, a singular point of awareness in a vast universe that somehow, impossibly, wonderfully, became aware of itself. Rest now, traveler through space and time. Close your eyes and float among the stars, knowing that you are home. You have always been home. Here, in this vast, mysterious, beautiful universe. Breathing gently, drifting, dreaming at